Hey, I'm Aaron Chai. I'll be doing a presentation about how superconductors work and how does it benefit us in the future. So there are actually three conditions on how they can display these properties. So they have to go between a certain limit. Each alloy or material has their own critical temperature, magnetic field, and current density in order to display the properties. So temperature is the most important. The lowest known will be 130 kelvins, and critical magnetic field, current density, they have to go below this limit in order to display superconductivity properties. So, and if you put them into a graph, this will be the range of each. So in this case, this material has this critical temperature, magnetic field, and current density. If they go below this, around this range, their superconductivity would show up the properties. This is the region right here. The closer it is to the origin, the more better it is. So there are two types of superconductors. Type 1 superconductors would be used pure materials, just the element itself. Now, when it comes to type 2 superconductors, scientists and researchers will use alloys. Type 2 will be alloys, like these two are the common materials used in order to do the experiments, as they are more easier to use and display the properties. So how do they work? When it comes to conductivity itself, there's always resistance, and the problem here is resistance. When there's heat, resistance actually make the atoms in that material or alloy vibrate. So this causes the current to go through resistance and have energy loss. So once they reach their critical temperature, the resistance will disappear. And since each material has their own different critical temperatures and states, so in this case, a higher critical temperature at 130 kelvins, that's the highest known so far. It will be easier to achieve superconductivity, and this is the goal currently, to find a high critical temperature material. And there's a Nernst effect which actually expels magnetic fields around it. So its own magnetic field is actually stronger than the countering one. And yeah, this is called the Nernst effect. And with this, there will be also superconducting magnets, which next. And we come to this theory, the BCS theory, which actually enables something called Cooper pairing. So how Cooper pairing works here is actually, before I get to that, when high temperatures, as I said before, that there will be vibrations in the lattice of the atoms. So in order for electrons to flow and affect this, for Cooper pairing to work, it actually needs the forces electrons to affect the lattice. In this case, in lower temperature, the lattice will have minimal vibrations, thermal vibrations. So with this minimal thermal vibration, movement by the electrons can actually has more effect on the lattice than the thermal vibration itself. And when this effect happens, it causes the atoms attract electrons towards each other. And next one, and we'll later on explain how this actually happens. So the diagram here shows that a flat lattice. So in order to attract electrons to electrons, usually electrons repel. But in this case, when electron move past a lattice, this shows only two. When this goes this way, it pulls up this lattice right here, the positive force. So when it attracts the second electron right over here, and so this proton goes up, this gets attracted to this direction, and there will be more lattice right here, and this will be attracted to that direction. So two electrons go past each other with no resistance. So this is the key part right here. And once they go past each other, this will be the side view. And this is the top view of how they actually go past each other through this way. So as you can see, they have no contact, they repel right in the middle right here. And when there's actually moving electrons, as we all know, there will be current and no resistance at all. So the advantages, when it comes to advantages, there will be numerous advantages. One is energy loss. Without resistance, there will be no energy loss, and this improves power cost and more efficiency. And of course, when it comes to this, more environmental benefit. We don't need the use of fossil fuel, and there will be less carbon dioxide emissions. And lower electricity loss too, because, well, low resistance, there will be no shortage and more power usage. So, superconducting technology also reduces the size and weight of generators by around 70%. Yeah, the generators, and the size of them, they'll be smaller, they're more compact, and with this, it can also lead to faster electronics and supercomputers, high-speed logic circuit systems, and sensors have more accuracy with DACs, digital analog converters. This can actually make it more accurate in order to use for experiments, for results. More accurate results can be made. So, also, there will be a stronger, when it comes to superconductors, they will have a stronger magnetic field. And this will be called the superconducting magnets. Superconductors themselves can become a magnet, and they'll be more stronger because thanks to the Meissner effect, as explained earlier. So, but there are limitations today that enable us to get close to daily usage of our technology today. So, as I said before, the lowest low will be 130K kelvins. With this temperature, it needs to be cooled to that point. So with this, there will be cost of cooling systems too, because with cost of cooling systems, for example, you have a handheld device and you're using superconductivity in it. It's going to need a cooling device, and it's probably going to be larger than that handheld device itself. And resources, like I said, the alloys I explained just now was actually quite expensive to find and also to use when it comes to technology. And the one thing about superconductivity, it can't use with alternating currents, because alternating current goes back and forth. For DC current, we need the electrons to go in one direction, but thanks to the BZS theory, it pulls the electrons in different directions, so it's technically AC itself, but using AC generators will break superconductivity. And chemicals, there are other alloys used also, but they are actually quite chemically unstable to use, not practical to use in our lives. So, the future of this, we already have the maglev trains, which allows faster speeds of today's trains. And with the future, if superconductivity is more advanced in the future, we can actually use it for everyday transport such as cars, and probably motorbikes will be replaced too. And our technology will be much more faster, and with faster technology, there's even a chance that we can improve all these technologies and cut out cost efficiency. Poverty can even be lessened, and who knows, once these are shot throughout the world, they'll be much cheaper and practical to use. And so that'll be about it. That's how superconductivity works, and this is most likely the probable future of how it is. And thank you.
Alright, I'm Alex, and today I would like to talk about the effects and roles of electromagnetic fields on the personal health of humans and living beings, as well as the effects on environment. So first of all, we'll be going upon the concerns regarding EMFs, which is the abbreviations for electromagnetic fields. First of all, the concern of EMF exposures is that it threatens our personal health and our well-being. And they hypothesize that it has links to diseases such as childhood leukemia. After tons of research, they have decided that the link between those two were actually very, very weak. However, they continued to research on more links with other diseases such as leukemia, brain cancer, breast cancers. And it was evident that there was no link to EMF exposure at all. However, they continued to investigate for practical methods to minimize the EMF exposure because they were worried about the vulnerability of exposure towards EMF, as we are surrounded by EMF technology such as cell phones, wireless routers, GPS devices, and the problem of residing near a power line station, which is one reason why residents nowadays are built distant from the origins of power lines, because the strength of magnetic fields upon structures are much weaker considerably when they are distant from their source of origin. EMF technology, if you notice, I focus on mobile phones because these mobile phones is what college students and a lot of adults are relying on. And we have to realize that it is also one of the technologies that relies most on EMFs because it receives radio frequency, or for short, RF, as well as EMFs from other devices to exchange information from a phone to another phone or to top up anything. And it emits a microwave EMF with 20 to 80% of radiation from a phone's antenna, which is capable of penetrating 2 inches of an adult's brain. Mobile phones has also a thermal effect on heating biological tissues and non-thermal effects of affecting the natural EMF frequency, which is something the EMFs the body we use naturally emits. The effects of EMFs is, first thing of all, electromagnetic hypersensitivity is actually an officially recognized problem in the WHO fact sheet. Why? It's because human body naturally uses EMF to function, especially the body cells. So it has been demonstrated in the Body Electric by Robert Becker that the body needs EMF to function no matter what. So we are surrounded by EMFs, and our body itself has EMFs. So the minimization of EMF exposure would be actually very, very difficult. Why? It's because objects around us could also act as an antenna for EMF, including water, which is 70% composed for the earth and 60% in the human's adult body. Ionizing radiation can also break bonds of human body, which causes things like cancer and mutation, which is also an increase in danger of health. So the Bio-Initiative Working Group has listed a few health problems related to it. And from this chart, we will realize that over here, a man would have a naturally 8 Hz of frequency in his body compared to all the EMFs around him, even non-ionizing radiation, which is said to lack in dangers towards our health. So the involvement of EMF is that in research, certain species are actually highly dependent on EMFs, especially those like sharks and rays who have electrical sensing organs to navigate and find their prey. But there are also species with weak defense mechanism which are also highly vulnerable to EMFs, and threats pose dangers to their survival. Moving on, the potential EMF health threats. So from going on into research of EMFs, they have created a list of dangers it poses towards our health. And though despite the association is really weak, they list it down for health purposes to give cautious. And out of the many, these are the list of it. And there actually would be more. So that's all. And the advantages I'll push on to Joyce. Thank you very much.
Hi, my name is Tira. You can just call me Tira. Now, I am going to present you about how does electric field affect the shape of flame and how it reduces pollution. Oh, what? What is that? How does it affect the shape of flame and how it helps in reducing the air pollution? Don't worry, I will explain to you in the next slide. Check it out. Oops, before that, let me tell the biggest problem that we experience nowadays, which is air pollution. Oops, air pollution? Yes, air pollution. Air pollution is caused by the imperfect combustion at the power plant at a certain area. The hotspot in a flame increasing the reaction between fuel and air molecule and lead to formation of air pollutant like nitrogen oxide, carbon monoxide, and particulate matter. So what is the solution to the problem of the air pollution? We might need a technology to overcome this problem. So stay here, spend time for our presentation. You will know the solution to this problem. Control combustion. So how to control the combustion? That's the question. And one way to control the combustion is by shaping the flame using the electric field. And we might need a technology to control the combustion. And there is one technology nowadays in the world that can help in overcoming the problem of air pollution. And the technology itself is called ECC, which means Electrodynamic Combustion Control. Check out the next video to know what is ECC. We introduce you Electrodynamic Combustion Control, which is commonly known as ECC. Oh, hold on. What is that? What is ECC? ECC is one project by a Seattle-based company called ClearSign Combustion Corporation in demonstrating how to manipulate the flame using high voltage electric field to prevent pollution from forming in the first place. As we stated the problem before, ECC can solve the air pollution problem. It's a one way to reduce the air pollution that we experience nowadays. The pulse field creates very powerful electrostatic force within the gas cloud can be manipulated to precisely control the flame shape and the transfer of heat. And generally speaking, combustion can be improved by manipulating electrically charged particles in a flame to prevent hot spot and therefore pollutant itself from forming. One must think, how does the ECC work? Well, the ECC technology at first will introduce a positive charge at a high voltage into the flame in order to remove the electrons. As all know, during the combustion, the electron will produce. And as the electron is less mass than the proton itself, their exit from the flame is rapid, and the abundant positive charge left in the particle begin to disperse as it repel to each other. Then the amount of voltage itself is adjusted by the computer to make sure the continuous adjusted the shape of the flame. When a charged species were to reach any grounded or oppositely charged structure, they would capture electrons, is it?
thus it will ground it. And in the ECC system, they make sure the electron or the burner nozzle to lower its potential. As it flattens out, the heat will distribute evenly. At first, they adjusted the shape, and ECC will make sure it operates directly into the flame. Because a more uniform flame shape means less fuel is wasted and exhausted as soon as more heat is transferred to the surrounding. Last but not least is the advantages of using ECC in shaping the flame by using electric field. Basically, there are two main advantages of using ECC in shaping the electric field. The first one is maintaining the shape of the flame at the burn area. It helps in giving the direct flame toward the burn area, and it gives the uniform shape toward the flame. In ECC technology itself, it offers a novel and unparalleled tool for shaping flames in extraordinary ways. For example, the first picture is the picture of flame without using a system, without using an ECC. As you can see, the flame is not directly toward the burn area. It's spread out. And the second picture is the picture when the system is engaged. When they use the system, the flame is directly toward the burn area, and to some extent it's caused reducing in the pollutant. And the last picture is the picture of uniform shape of the flame after it engaged the technology of ECC. The second one is the advantage of using ECC for shaping the flame is reducing smoke forming, nitrogen oxide emission, carbon monoxide, and soot. This one is because the increase in air and fuel mixings in the combustion chamber, it reduces because more fuel is burned. So by using ECC, it produces a agglomerate and easily remove particles downstream, so that people can easily pick up the particle to remove it without having it to disperse into the air and cause the air pollution.
So, have you kindly figured out what is ECC means, how it works, what is the advantage of using ECC? And generally speaking, ECC has invented a technology that can be used in a power plant to control the combustion by using electric field in shaping the flame. Then, to some extent, it eventually gave the advantage to the world nowadays in reducing the air pollution. Wow! It is such a great invention. And that's all from me. Thank you.
Hello everyone, I'm Joyce. Today I will be presenting electrostatic precipitator. Hope you guys will enjoy. Let's start the slides. First, I will introduce you what is electrostatic precipitator. Electrostatic precipitator is commonly used in the thermal power plant or steam power plant. Then what about its function? Its function is to remove fly ash from the electric utility boiler emissions. Besides that, it also can be used in different industries. For an example, power, electric, cement, chemical, metal, and paper. Now, let us see what's the effect of using electrostatic precipitator, the before and the after. Before using the electrostatic precipitator, the gas released are actually full of dust. And when the gas is released, it will actually cause to air pollution. Then what about the effect of after using the electrostatic precipitator? The gas released from the power plant are full of dust. However, when it passed through electrostatic precipitator, the smoke that released are actually cleaner than before. Then what about its basic principle? The basic principle of electrostatic precipitator is it is actually act as a highly efficient filtration devices. Its function is by using the force of an induced electrostatic attraction. For an example, like it's a magnet, light charges attract and light charges repel. It also has a high voltage electrical field, which also named as corona, around the electrode, and it ionizes the gas particle and flowing gas. Let us move on to the basic component of electrostatic precipitator. The basic component of electrostatic precipitator, it is power supplies and controls, gas distribution systems. The next one will be wrapping systems, hoppers, discharge electrodes, and the final one will be collecting electrode, which also named as collecting plate. Don't understand what is the function of each basic component? No worries, I will explain to you what's the function. The first basic component that I'm going to talk about is power supplies and control. Power supplies and control are actually used to provide voltage to the electrical fields at the highest possible level. It is also used to control the voltage to avoid causing sustained arcing or sparking between the electrodes and the collecting plates, because this may damage the electrodes and the collecting plates. The next one, I will be talking about gas distribution system. Gas distribution system is actually a one electrical field or bus section of an electrostatic precipitator is by itself an independent precipitator. Its operation is also governed by the inlet gas and dust conditions, as well as the collecting plate and discharge electrode geometries. The next one will be the wrapping systems. Wrapping systems are time control systems provided for removing dust from the collecting plates and the discharge electrodes. It is also functioned by electrical, pneumatic power, or mechanical. Hoppers. Hoppers are used to completely discharge dust load on demand. And here's some pictures for you to see the examples of wrapping systems and hoppers. This is the wrapping system and this is the hopper. The final one will be the electrodes. Electrodes are the most important components in electrostatic precipitator, as it helps electrostatic precipitator to carry out the filter function. There's two types of electrodes in this device. The first one will be discharge electrode. Discharge electrode provide voltage that generate an electrical field between discharge electrode and collecting plate. It also carries the negatively high voltage. The next one will be the collecting plate. Collecting plate collect precipitated gas particles until they are moved to the hopper. It carries positively high voltage. After finished talking about the basic component of electrostatic precipitator, now let us talk about the working principle of electrostatic precipitator. There's two stages. During stage 1, the electric field is immersed due to DC terminal arrangement. The applied negative voltage in discharge electrode is increased until it produces a coronal discharge, which can be seen as a luminous blue glow around the discharge electrode. Due to the formation of coronal discharge, free electrons are emitted with high velocity from discharge electrode. These fast-moving free electrons strikes the gas molecule, thus emission of free electron from gas molecules takes place. The positive ion molecule moves towards the discharge electrode by electrostatic attraction. As a result, using gas molecule, more free electrons are emitted near the discharge electrode. After talking about the stage 1, now we will move to stage 2. During stage 2, the electrons leave the strong electrical field area around the discharged electron. They start slowing down. This free electron again strikes the gas molecule, but this time they are captured by gas molecule and became negatively charged ion. As the gas molecules are negatively ionized, they move towards the positive electron, which also named as collector electron. Let us see the third picture. In this picture, this negative ion fills the space of dark particle and becoming negatively charged particle. And for the last picture, these particles are captured by the collector electron. Let us move on to the advantages of using electrostatic precipitator. The advantages of using it is because it is very high efficiency in removing small particles like smoke, mist, and fly ash. The normal mechanical cannot remove small dust particles below 10 micron. However, electrostatic precipitator can do that. Under these circumstances, electrostatic precipitator has higher efficiency than other normal mechanical. It is also very effective for high dust loaded gas. Its efficiency is as high as 99.5%. Its maintenance fees are also lower compared to other separators. The next advantage will be it is very easy to operate compared to other separators. The dust removed also can be removed in dry form and it can operation in dry or wet circumstances. Sadly, there's also disadvantages of using electrostatic precipitators. For the first one will be, for the modern thermal power plant, direct current DC is not available. Hence, to operate this kind of electrical equipment, AC needed to convert to DC, and this eventually will cost a lot. Second, the running charges is also high as the amount of power required for charging is considerably high. And the next one will be, the space needed for electrostatic precipitator is larger than the normal wet systems. The last one, the efficiency of the electrostatic precipitators is not maintained if the gas velocity exceeds the plant is designed to afford with. The dust carried with the gases increases with an increase of gas velocity. The efficiency of electrostatic precipitators decreases when the gas flow increases. Thank you everyone for watching my video. Hope you guys will enjoy and see you next time. I'm Joyce.